Okay. So Steve, I see that you put a lot of details about KubeCon Shanghai. Do you want to start with that?
Sure. You know, the prep for KubeCons, there's two of them, of course, but Shanghai starts immediately. I'm flying out in less than 24 hours. So that's starting next week. And there are some, what I did is I searched the agenda for the word edge. So it's possible that I missed some edge IoT related things, but those are the ones that immediately showed up. And that top one is by Dan Cohen, the head of the CNCF, in the keynote. So that that session, nearly all computing is edge computing. I'm curious what that means, but I guess I'll find out. The keynotes, by the way, are normally broadcast. If anybody cares to watch it and is in a time zone where you're awake at whatever hour that turns out to be.
Yes. Can you, maybe we should post a link to the recordings to the Slack channel so that people.
Yeah, they won't. In my experience lately, they will record keynotes, and beyond that, generally the answer is no. They have not been recording sessions, although it's sporadic. So sometimes they get recorded, sometimes they don't. In general, the decks will be posted, but that is dependent on the good behavior of the speakers. But I'd say 80% of the time you can get a deck afterward. Maybe I take it up to 95 if you find the speaker, get a contact address and ask them. I don't know if Cindy is here, but I think that except for the Dan Cohen, all of those talks are with her organization. I don't see her on the list though. And in the Slack channel, Cindy mentioned that she was going to be there, and I am. I don't know if anybody else is planning on being there. If anybody is, I'd invite you to contact me, but I'm not sure how you can best find me, because as I understand it, my Gmail is going to be blocked, my Slack's going to be blocked, and maybe ask somebody at the VMware booth to find me.
Hi, this is Ito speaking.
Oh, hi. Yeah, I saw you made a comment that you were going to be there too, right?
Yeah, I'm going to go to KubeCon China also, and I want to talk to the Cindy and you in the KubeCon.
Okay. I'll be there the whole week, so hope we can find each other.
Okay. So maybe I'll send a message by Slack or something.
Yeah, the trouble is I don't believe that, I think Slack is blocked by anyone with normal Chinese internet access, which would be the conference and the Wi-Fi. If you have some mechanism for a VPN, you might be able to use Slack, but then the person you're trying to contact may not be able to use it. So I'm not sure how reliable it will be.
Oh. Okay.
You're welcome to try. I mean, I'll attempt to read Slack, but I'm not sure that that attempt will be successful.
Oh. Okay.
Steve, are there any interesting sort of soft anecdotes or stories from the Heptio team about Edge, as given they've done a fair amount of consulting?
What you're referring to for others is that VMware and Heptio announced an agreement to join.
It's just the announcement. It's a pre-announcement.
Right. So I've been advised
you can't say anything.
Cannot say anything until it closes, which is expected sometime before the end of the year.
Yeah, no worries. I know the drill. I thought it had already closed. So yes, you're still in the letter of intent, sort of in due diligence, so you can't say a word. I will be interested to know, given that they've done some pretty good, you know, in the field, in production consulting work, what they will bring to the conversation for this fast.
Yeah, I mean, certainly they bring a bunch of really smart guys. Yeah, that's always useful.
Yeah, I started at Google like 8 or 9 months before Joe left or so. Joe Beta. So at that time, the whole cloud team at Google was much smaller.
Yeah, and then it seems like the trend was, I started working on Kubernetes when some of those people were still there, and I don't know, there was a debate on who was going to win container orchestration, but I still remember going back to my management saying, if there's any justice, the smartest guys in the room are on Kubernetes.
I do think it'll be interesting, and this I think this is kind of relevant to the edge conversation, is that there's always some risk of kind of curated forks for a certain purpose. If you think about what kind of happened to OpenStack with people who were trying to find ways to fork and add value, that there could be some edge flavor of a Kubernetes fork somehow that somebody kind of tries to market as something, right? Like you have to use this version of Kubernetes because we've done all this optimizing for the edge.
Well, there already, I would contend, there are KEPs, there are just discussions in various working groups. Not all of them are in this one, by the way. I mean, so some people took the tactic of, or their first impression, they being engineers, were that this is the component of Kubernetes that really needs to be modified for our use case, whether that be kubectl or, whatever that component might be. And they went at that SIG and proposed whatever change they wanted to make. And it's more like an approach from how you do it rather than the actual use case, which should be homed in this working group. But they're scattered all about. And some of them have proposed these, even up to the point of maybe discussing it in front of architecture committee meetings. But I get the impression that it's important to some of these people to the point where if they're told that they can't get it in or they don't like the CRD mechanism, they can always pick up their cookies, fork it, and it's just the way open source works. And I think whether that people will have these changes because I think they have legit use cases for them. The only question is whether it's accepted as part of the mainstream Kubernetes, whether it's accepted but in a modular thing that's out of tree, or whether they outright fork it.
Yep. Yeah, I was describing this to somebody where I kind of liken it to a stew that's always evolving. And as long as someone like Google or some kind of core collective that's doing the main contributions keep adding enough value to the main pot of stew, anyone who ladles out and kind of does a derivative, they'll keep dipping back into that main pot. I think what happened to OpenStack is the peripheral projects started adding more to their piece than the main tree did. And so the main tree just kind of
and people who build other things in the tool chain couldn't count on it working with these spin-offs, which was pretty ugly. And the other thing that I think I don't care whether people fork it so much as whether they keep it open source. I mean, that's a big deal. And I'm not sure that everything that went down in certain other projects like this stayed with that mentality of, extending it, but keeping a community going where others can see the work and join in and contribute to it. And as long as that happens, I'm in favor of it in whatever mechanism people seem to find expedient.
Hey, I'm seeing Harold Mueller's here, and I think we had a note from last time that maybe the Siemens Lightning Talk presentation. Harold, is that something you came today to maybe share?
Yes. Yeah, sure.
Shall we move to that?
Sounds good to me.
Yeah.
Okay.
That's good.
Okay, so then also a colleague of mine, Srinath, has joined today because what we would like to do is to give first a short introduction about an explanation about the use case, and then Srinath will give a short demo. at the EclipseCon, we showed, or I showed a video of that demo. We tried to do that live today. So let's see whether that works. Okay. Let me see whether that the sharing works.
We see a desktop and nothing on it.
Okay. Now you should see a full screen
Okay, we got it.
Yes.
presentation.
Yeah.
So actually, I'm not sure whether I should call it a use case for IoT edge computing, but it is a project, or what we call seamless computing, and I'm gonna explain you what we mean with that. So let me start with a quick example, and I'm using that often to motivate internally and externally why we are looking in this thing of seamless computing. So as you know, we are into industrial systems. So everything we talk about software is in an industrial context. So it's software that runs in plants, in buildings, in large civil infrastructure things, whatever. So it's this kind of systems that we are looking at. And I took a typical example, which is a SCADA system. So you probably all know SCADA systems, and it's so it's a distributed software system that has a couple of software components that run on different hardware devices. So you have something that picks up information that sits in the field somewhere. Sometimes it's a PLC, sometimes it's some sort of sensors. You usually have drivers that convert protocols to something that is understood by the SCADA system internally, and then you have the SCADA core that sort of processes all the information it gets. It creates alarms, for example, if some values reach a certain threshold, or for combination of values. It has a historical database where it stores all the events, and then finally you have also a human-machine interface, user interface. And if you look at where these components are running, they are running on very different systems or kind of hardwares. So from embedded devices on the very low level, some things might run on-premise, so what you might call in an edge domain. There are some things that could run in a sort of a data center. Maybe that's a private data center of the customer, but it's sort of an IT environment. And finally, there might also be components that run in a cloud, maybe even a public cloud. And if you look at the characteristics of those hardware systems, you realize that it's very difficult to implement and to operate such a system in the field, because you have those software components in these very, very different hardware environments. But you have to make that all play together. You have to update all of that so that it works together. You have to deal with the complete life cycle of this complete system, because it only works when the system works, and when the things are compatible at all the times. So that is sort of the challenge that we want to address. And how we want to address this, this is what we call seamless computing. So, so the vision is you have this infrastructure with these different kinds that we showed earlier. So from embedded devices up to virtual machines that live in the cloud. And on the other hand, you have a distributed application. So it's an application that consists of several components that interact with each other, that talk with each other. So they exchange information, and they compute certain things with this information. And now the vision or the idea of seamless computing is, what if there is just the guy who implements this complete system, he just implements these application components. He provides them with let's say, certain characteristics or parameters, and then he throws it into this seamless computing automaton. And the seamless computing system would take care of where to run which application component in this range of infrastructure. So that means we would like to achieve that we have a harmonized software environments for all these hardware domains that we show on the left-hand side. And so that when you develop your application, you don't care where your application component would run at the end. So where it would run, that is determined in the ideal case at the deployment time, but maybe even later at runtime, you might be able to change that. And that is based on allocating the workloads based on constraints. And the system can be kind of self-optimizing. So it can, based on the current situation of your infrastructure, the current situation of your application components, find the best solution where to run the different components. That may sound pretty familiar to you, and it should. So this is sort of, you could also call it fog computing. So if you read the definition of the Open Fog Consortium, that is something that they have in mind. However, there are other definitions of fog that are quite different. That's the reason why we didn't call it fog computing, or why we gave it also a different name with the seamless computing, to stress the fact or the characteristic of this system to seamlessly combine edge and cloud domains. So that's actually what it is. So we want to make it fully transparent to run software across this continuum from edge to cloud. Okay, so this is more like the vision, or this was more like the vision, and now we are coming closer to why this might be relevant here as a use case, because we also have started to implement or to do some proof of concept using Kubernetes. And the seamless computing concepts applied to Kubernetes means that we package the workloads or these application components into containers, and we orchestrate these containers using Kubernetes. So to do that, we build a cluster that spans over different compute domains. So it's a cluster that contains nodes that run in the edge domain, that also run on cloud nodes. And we use or currently use the existing Kubernetes scheduler using some of the scheduling features to distribute the workloads so that they go where we want them to go. So that's the basic idea. And so now we come to the short demo. And what we are showing is on the left-hand side, so it's a very simple distributed application. So it consists of two application components. The lower one is an application component, and it's a very simple IoT app, if you will. So the lower component is a component that reads a sensor value. So that's something that is attached to an I/O. Where a sensor is attached. So it reads that value, transforms it into something that can be transported over the network. And the second component is the user interface component. So that's something that takes the values from the sensor. You could assume that it also stores it, has some sort of a database, and it displays that value using a graphical user interface. So that's this very simple two-component distributed application. And on the right-hand side, we have the infrastructure. So it consists in principle of 3 nodes. So we have 1 node in the cloud. We have 2 nodes on the edge. So both are embedded systems. And one of these embedded systems, it's the sensor node. That is the node that has the sensor attached. And The second node is also an embedded system. It's both, as you can see, Raspberry Pis in our case in the demo, that could also run containerized workloads. And now in the first scenario that we show you, we just deploy this application onto these 3 nodes. And what you will see will happen is it will deploy the sensor reading component to the node that has the sensor attached. So, and the second component, the user interface, will go also to the edge node. That is because, let's assume it's cheaper to run it there, so we don't need resources in the cloud. It's lower latency, so that's why we want to schedule it, if a node is available and capable to run that user interface components, to run it in the edge as well. Then second scenario, what we do is we trigger a redeployment. So we take away this edge node that runs the user interface component. And what will happen is, so the user interface component will be redeployed or rescheduled. And now the system picks the cloud node as the only possible node where it can run at that moment, and will deploy it on the cloud node, and we will see the system up and running again after some time. Okay, any questions regarding this presentation?
So I have a bunch, but I'm willing to sort of hold them till after the demo. Maybe we go all the way through and then we just have a discussion. What do others think?
Yeah, me too. I've got a question, but
Okay,
let's see the demo.
cool. So then maybe, Srinath, are you ready?
Yep. So, so let me share my screen. Okay, there we go. Yep. All right, so do you guys see my screen?
Yeah.
All right, so so as Harold mentioned, this is a very basic Kubernetes cluster. So so I installed it using kubeadm. So the master node runs in AWS, and you have 2 minion nodes running in 2 Raspberry Pis. So I also have like a kubectl proxy running on my machine, so that I can access the UI directly from my machine. So nothing fancy stuff. So what I'm going to do right now, as Harold mentioned, is I'm going to start a deployment. So I'm going to do that directly from the UI here. So I have a deployment file here. So let me just start it first, and then I can explain what goes into deployment. All right. So the deployment basically has 2 components: the sensor component and the user interface component. So the sensor component always needs to run on the Raspberry Pi node that has a sense hat in it, and this is achieved by using node affinities and node labels. And the user interface component is preferred to run on the second Raspberry Pi node, but if that is not available, it can also run on the AWS node. So as you can see, I use node affinities here. So it says that like it's preferred to run on the compute domain on the edge using an increased weight for this, but it can also run on the AWS node. So now let's see if the pods have actually started. Yes, they have started right now.
So maybe a quick question as you go through the demo, because one of my questions relevant to that affinity piece. How do you specify the architecture in the image, in the container image, if you have an ARM image?
Right. So basically, the sensor image is made from an ARM-based Docker image. So there is no x64 version of that.
Sure. And the
So
one
that
that
runs
the one that can run either on the cloud VM, which is x64, the
right. So for the user interface thing, we need to have two separate images, one for the ARM version and the other one for the x64 version. Okay.
where do you specify the
So I don't specify that here. So I don't specify that here. So the thing is, the image name is the same for both. Just that I have these things stored in the local cache for both these nodes.
Okay, that's exactly what I was trying to get to. Is how did you do the auto selection of the image based on which node it lands
Yeah,
on?
but I think with the new
So you're
multi-arc
saying they're configured to use a different image repository? Is that what it amounts to?
something like that, or I guess you can also use the Docker multi-arc images. So, but at the end of the day, you still need to have two different images.
Isn't there like a manifest list that can do that?
Exactly. So that's
With
what
Docker?
Docker multi-arc images do that.
Yep.
Okay. So the deployments have started, and I guess now you should start seeing the UI. Yes, you see the UI and you see the values coming in. So that's like a very basic deployment here. And as you can see, if you go into the pods, the sensor node runs on the Raspberry Pi that has a sensor in it, and the user interface runs on the Edge node. Now, let's try to force a rescheduling here.
Maybe one quick question while you're in this state of affairs. So the UI is a Kubernetes service, right?
Correct. Yeah.
And what was the endpoint you were hitting? Was that so is that a proxied port to the master to get the because if the service is in the centralized cloud hosted control plane,
right?
Is it available local to the node that's running it without access to the master? Or
yeah, so in the sensor application, I have a REST API running, and this is exposed using a service in the master node, and the user interface then hits this service to get these values from the sensor node.
So it's routing to the master as the endpoint, which is then using kube networking to get down to the node on the on-prem. Okay, and I know this is a demo, so I'm not looking. I'm just trying to understand how you may have attempted to solve some of those things that were not easily solved out of the box. So
yeah, so that's basically the idea. So I created a service with the sensor API endpoint, and then I used the user interface to hit that particular service. So at the end of the day, it still needs to go through the master to hit the sensor node. Okay. So now let's trigger a rescheduling within the Kubernetes master. So for this purpose, I'm going to delete one of the edge nodes. So so like I said, so there are like two edge nodes. One has the sense hat, and the other one is a normal Raspberry Pi. The sense hat cannot be deleted because the sensor application needs to be run on the on the Pi which has the sense hat in it. So let's delete the other Raspberry Pi node. So I'm gonna just do a kubeadm reset here. Okay, and then I come back into the terminal, and then I do a kubectl delete node so that I can delete the node from the cluster. All right, so now if I go into the pods, yeah, this is also one problem that I'm facing, that every time I delete the node, I have to restart the proxy. So let me just.
it may be that you're proxying through that. No.
I don't think I'm proxying through that node. I guess the proxy directly hits the master server.
Yeah.
Yeah, what is the networking plugin you're using here?
So it's so basically what I'm doing is I'm running a local proxy server here. So what kubectl proxy does is like
And I think Steve means like, are you using WeaveNet? Are you using?
Yeah, what the
no,
CNI?
no, I'm using Flannel.
Okay.
Yeah. Right. So you can see the user interface port has been rescheduled onto the AWS cloud node, but the sensor node remains on the Raspberry Pi sensor node. And you should see the UIs back up again.
Yeah, and the nice thing is that if you did have that service behind a load balancer and a DNS name, that's very stable. So that doesn't change
But
based on that rescheduling of the pod, right?
Right. So that doesn't change. But I think something happens when I delete that pod here. For example, maybe this goes through the Raspberry Pi Edge node, and that's why I have to restart it again. Don't know. That's anyways. So the idea here is the dynamic rescheduling of applications. Currently in Kubernetes, you can achieve it by triggering a condition that needs to start the rescheduling. Because as far as I understand, Kubernetes does not really try to alter an existing running scenario, right?
Mm-hmm.
For example, if we say that Kubernetes needs to reschedule the pods, if a new node comes in and that if you assign the applications to that particular node, you would have a better optimized scheduling scenario. But that doesn't work with Kubernetes. Kubernetes always try to maintain the current state as it is. And only if you actually trigger some failure scenario like I did here by bringing down one of the nodes, Kubernetes would actually do that.
Yeah, so for example, if you brought back the Kubernetes Raspberry Pi node on the edge,
Yeah.
even though it's preferred, Kubernetes will not proactively reschedule it.
Right, exactly. Yeah. Okay.
Great.
Any
Steve,
more?
I've been asking a bunch of questions, so I'm gonna yield before I ask more. Steve, you're muted. Steve, we're not hearing you.
Oh, I put my questions in the chat, so I guess I can read them now. But
Okay.
first one is, how well does this solution work when your edge location loses control plane connectivity? And suppose the edge location cycles power while this happens and comes back disconnected. Is your use case something, in my experience, a typical SCADA use case would expect to operate even if this connectivity to the central cloud is down?
Yeah, I mean, I would say that the applications that are already running on the system would continue to run, just that you wouldn't see that node in the cluster. I don't think that would probably bring down the applications or anything like that.
Yeah, it wouldn't, but I think it's not uncommon to expect that you'll have some, let's suppose this happens. A regional power loss takes out the location where this SCADA data collection is running. Power comes back, but internet connectivity doesn't come back. What happens?
So like I said, so the running applications, if they require internet connectivity, obviously they won't run. But if it is something that can run on the system without it, then they would continue to run. I mean, just that.
Well, they discontinued to run when they lost power. So what happens?
You mean that the nodes would also lose power? Is that what you're saying, Stephen?
Yes,
The nodes would also lose power.
Right. They lose and then regain power, but when they regain power, they can no longer connect to the control plane.
I mean, this scenario is sort of abstract. I imagine that, especially with the Siemens control PLC gear, that all of the edge critical functions continue to run as they were. And this is a remote visibility kind of reporting operation that if you're losing connectivity, you lose the remote visibility, but it doesn't mean that the primary historian and PLC workloads don't kind of.
Well, if the historian is running as a Kubernetes workload, then it is important.
Yeah.
My experience, if the operators lose visibility on this stuff, that's pretty important.
Yeah.
Oh, and if the nodes don't have to talk to each other through the cloud too, right? You don't. That's the reason you would not want that if you lost network connectivity.
So I think you would have to look deeper into the scenario, what fails and what comes back in which order and something like that. I agree that probably not in the most cases it would not be a sufficient behavior that you have. But let's assume that the nodes come back and also the connectivity comes back. So then you would have the master again being able to reschedule things. Of course, this would need some time or take some time, and then you would have to argue whether this is fast enough or not. I think so. Why we used currently we use this single cluster setup with the master in the cloud and some of the nodes in the edge is more like driven by the fact that we think something like a federated clusters are not on the same level in terms of features that you have to schedule workloads. In the end, I think you would need something that that also enables you to continue to run even the workloads in the edge when the connectivity is down to the master. Be it that you have sort of a federated cluster and you have one master in the edge and then you have the federation master somewhere in the cloud that manages several edges and components in the cloud, or be it that you have some sort of availability mechanisms that kick in when the connectivity goes down. And similar thing that that Cindy has shown us a couple of weeks ago in the Huawei scenario.
Yeah. I think you need to deal with things like a split brain condition too, where because in your example where you remove that Raspberry Pi and move the workload, a network failure would trigger that, so you would have that workload running in two places.
Mm-hmm.
Yeah, exactly. So that's also one thing that I noticed here is that, let's say, if for some reason the node goes down, Kubernetes would automatically restart or recreate the applications in the existing nodes. And then later when the node comes back, it would see that there are two copies of the same application running. So you would bring down one of them.
Yeah.
To make sure
and
that
and you'd want to prefer it to bring down the one in the cloud in your example in the cloud,
exactly.
right?
Yeah,
So,
yeah.
But the communication, just to understand, the communication between the Raspberry Pi sensor node and the Raspberry Pi UI node does not occur if neither of them can reach the master.
that seems like a problem.
Is that true? They're routing through Kubernetes. You're using Kubernetes services to communicate between them, right?
Yeah, exactly. So that's true. So if the master is not reachable for the minion nodes, then they wouldn't be able to communicate with each other. That's
so
true.
I mean, I just want to acknowledge that I think this is awesome, because I think what we really need is sort of 1,000 of these quick experimental things, and not expect them to be final solutions or ready for production or any of those things, because these are really useful for sort of exploration and discussion, not so I don't
identify what needs to be improved, basically.
Yes,
right.
Yeah, definitely.
Right.
Absolutely.
So all of these comments, I just want to make clear, we're not sort of saying, oh man, you deploy this to production, you're crazy.
No, and that is far, and as you might imagine, this is far away from production.
Yeah, and
So
I just want to acknowledge.
So
Yeah,
the
I
main,
think networking is a big part of the issue when you get down to it. I mean, it isn't just that they can't reestablish, but even the security, like, you know, if by default every edge node can get at every other one, and you've got thousands of them out there, you've got a big security issue of physical security on these, giving a vector to get at all the others potentially.
I did have another technical question in terms of when you set up this, did you just use kind of private networking and have direct IP access to the master? Or did you use any kind of virtual kubelet?
Right. So that's a good question. So what we ended up using, we had the same problem that the master node need to be able to reach these minion nodes, and since these guys are inside a NAT network, we had to create like a VPN tunnel between the minion nodes and the master, so that they end up being in the same network.
Have you looked at the virtual kubelet interface as an alternative to that at all, or?
No, I haven't. What does that do?
So it basically exposes the contract of the kubelet to the master, but through essentially a pod that runs in the cluster as a proxy, where the implementation of the virtual kubelet is entirely an implementation detail. So, for example, you could use, some other secure like MQTT protocol down to a remote node as essentially a way of tunneling that communication between the master and the edge.
Okay, cool.
There's pros and cons to it, which is why it's on my list to get some time to try and kind of experiment more with that. But that's why I was wondering if you had already done some.
Not really. I haven't really done that, and I think that's a very interesting idea, and I would definitely be interested in trying it out here.
Another question for kicking around is whether anybody thinks that the things going on with service mesh might have some utility in these edge use cases as a means of supplementing behaviors in the default CNI type networking at the lower levels of the network stack.
Potentially, especially when it comes to using Envoy locally to expose. I mean, I just don't know how you're going to do that without having a full cluster on edge, right? As far as exposing an Envoy route.
Right, and maybe the resources of some of those pieces of technology are a little intense for these edge cases, but something worth considering, because I think a common theme is that networking issues are sticky in this use case.
Speaking of, like, I'm gonna chuckle a little bit at these naming things, because the fog, you're saying how this is sort of a distinct facet or fork from fog computing, but then if you look back, ubiquitous computing is probably the first term moniker that was applied to this. That was back in '88. So this is definitely been kicking around in many forms for a long time. The question I had in your seamless computing architecture was, you had this all the way down to kind of the microcontroller level. What was at least the imagination of how you might tackle something that was crafted as a Kubernetes workload, and then are you imagining somehow recasting or code genning some embedded code for microcontrollers based on that, or what was your kind of initial thinking there?
Actually not. So currently we see the border really in systems that are able to run containers and that can be managed using Kubernetes with that implementation. You might think of extensions to that, but currently that is not. So that is not something that is in reach of our thinking in the next time. So really, currently we just put that there sort of with the understanding that we know that systems are growing, compute capacities are growing even of embedded systems, and things get bigger and more capable. So many nodes or even embedded systems that maybe today are sort of microcontroller based and very, very constrained. Tomorrow, some of them might go into the direction of running standard operating systems and container environments. So that's the way we are thinking currently. And then at least we show them, because we want to make clear that we have to be able to connect them at least. So they are not really part of the managed part of the system, but they are part of the overall system in the sense that they can be or have to be. We have to be able to connect them and deal with all sorts of constraints that arise from that fact. Like we shown with their sensors connected, or there's a PLC connected to certain nodes. So we have to constrain the scheduling of the software components to those locations. Or
so it does seem to me that if I were to pick one thing out of this that I would sort of want to make sure we capture and highlight in our overall work is around the potential value of a more aggressive scheduler capability to proactively sort of rank higher the value of rescheduling, to rank that higher than the interruption that would incur if the user had a reason for that.
Yeah. There's maybe another aspect that we have not shown in this demo, or I have not explicitly mentioned. But one thing where we think currently the Kubernetes scheduler has certainly a limitation, if not a blind spot, is if you come into a topic that I would call latency-aware scheduling. So consider you have a distributed application that has some latency constraints or latency optimization demand between at least two of those components of this distributed application. And you schedule these independently. And you want to make sure that Kubernetes keeps these constraints. So let's say we have component A and a component B, and you want to make sure that the round trip communication time or cycle time that you have between those two components is below a certain threshold. And how can you make Kubernetes schedule these two components so that this constraint is kept?
Do you think the zones and regions would manage to do that for you, or would you need something more advanced, like a custom admission controller?
Yeah, that. So we have the feeling that we need something more advanced.
Hi guys, it's Daniele speaking from SBK. I can bring some. Can you hear me?
Yes.
Yep.
I can bring some feedback from our experience. We did a sort of proof of concept, a sort of prototype that managed this kind of situation, like placement of containers based on requirements between two or more microservice or containers. And these requirements could be, of course, traditional requirements like the one already managed by the Kubernetes scheduler, like CPU, RAM, etc. But we also added some additional constraints that are based on network capacity, meaning latency, bandwidth, etc. So yeah, we already did some tests on these, and probably we can share our experience in one of the next calls. Yeah.
So that would be really great. So I would be
yeah.
really interested in how you did that and what your experience is.
Let me share a couple of links on the chat so you can have a look at what we did. We are preparing a self-contained demo environment that will let people try what we did in their own laptop. But it is not ready yet. But yeah, we are available to demo or to show you what we did. We also worked on scenarios like the one you presented in your demo, and like the one when you detach the connectivity, when you cut the connectivity between the master and the edge node. And what we experienced is in fact that all the services provided by Kubernetes, for example, the DNS service, is not anymore available. So meaning that two microservices running on the edge cannot talk anymore to each other because they cannot contact the DNS that is probably deployed, the Kubernetes DNS that is probably deployed on the cloud.
Mm-hmm.
So Daniela, do you maybe want to do it on the next meeting to have like a session and demo like this in 2 weeks?
Let me try to organize. I will give you a confirmation early next week because we have a lot of things to carry on. And
of course, there's no rush. Whenever you're ready, just send a message to the Slack channel, and
of course,
we'll put it in the agenda, right?
Okay.
But I was thinking in all these talks that this might be a good start. As you said, like one of the missions for this group would be to document all these use cases, create a demos like this, and then try to move things forward. So when I first saw Harlow's demo, it struck me as a good starting point to do all this. So yeah, it's not a complete solution, but it's a good start that we can reasonably well document and show to people, and then start to digging up into all these edge cases, like the connectivity and how to deal with the multi-architecture things, and introducing virtual kubelets. But as a base, I think if there's a will to start with kind of creating like a small open source project out of this or putting it up somewhere on the GitHub where people can start playing with things like this. I don't know what you guys think.
Yeah, I think it's a good idea. And as Preston, as you said, it's a very simple demo, but it already shows or brings up some of the challenges that you have. And I think if we construct a couple of those simple things, we will bring up all the things that or hopefully most of the things that we need to solve and extend Kubernetes with to manage all these things.
Just a logistics note. I think I should still be able to make it next. The next meeting falls on the Friday following Thanksgiving in the U.S. So there's a bunch of U.S. folks typically that may be off. But I don't think. I mean, this is a very international group, and I don't know about you, Steve, but I should be able to kind of still duck in. I'm not proposing we change anything about it. Just making an observation.
Yeah, I'm not sure if I'll be able to make it or not. I'll try,
so
but
that's on the 23rd, right?
To go to the reInvent conference starting that week, and I've got it sandwiched in between some other things.
And we're recording these now anyway, so there's always that.
Yeah.
Where are you posting them, Dejan? Are you integrating them into the agenda notes?
Yeah.
Okay.
By the way, could we get a link to this deck? Or could you put it in the notes?
Yeah, I can do.
Perfect, thanks.
I can do. We also started, I think last week we got the comment already, started to kick off our internal process that we have to follow. We put something of the code of this demo online. So hopefully that will work out in a couple of weeks.
So I'm not sure as a working group, do we have, I think we should have some space to put the material like this, right? And present it. So maybe we can try to do that under the umbrella of this working group if that's okay with the Siemens as well. Is there like a main contributor for now of that piece of work?
What do you mean, Dejan? I didn't get that.
So maybe try to find a GitHub place under this working group where we can host the material for this demo, for example.
Yeah, if there's one way to do it, if it's simple links, to just put them in the running meeting notes here.
Yeah.
The Google Doc, and less formality than GitHub, where you're going to have to, under the Kubernetes project, appoint approvers and reviewers.
Yeah,
and it makes it, I think, for people to be willing to invest the work to put relatively casual and low lifetime links. My prediction is they'd be reluctant to go do it. And maybe the Google Doc is better.
Yeah, I second that. It's just low friction and people who are, then we have also fewer places to point people who are looking for sort of the running work journal of this group.
Yeah, and if somebody was thinking about one that based on my experience is poor, you can post doc links in Slack, but Slack isn't really good for searching for things. And so I don't think that's a great solution, but putting it in our meeting notes for now, it's small enough that.
My only concern is that meeting notes will they keep growing and.
Yeah, you can restart it annually.
Yeah. Okay.
Yeah, and the truth is, a year from now, the Siemens demo is going to be a lot less relevant, right? I mean, I think Harold and Sirat, they'd agree that this is a point in time. This is the state of the world right now. But a year from now, we're not looking for the link.
Yeah, makes sense.
I'm going to have to drop because I have another meeting. But thanks, everybody.
Thanks, Harold and Sirat, for presenting. That was great.
Yeah.
Thank you.
Our pleasure.
Bye.
Thanks, guys.
See you. Goodbye.
See you. Bye. Bye-bye.
Hey, Dejan.
Hey.
Yeah, I have a question about the meeting time.
Yeah, go ahead.
It's
there was a problem in the I noticed as well in the calendar link. Is that what you're referring to?
Yeah, that's it.
Yeah, I'll change that next week just to make sure that the calendar invitation same time zone as the one posted on the GitHub.
Okay, so UTC 3 p.m. is correct.
Yeah, it will stay like that for now.
Okay, thank you.
Okay, cheers. Talk to you another time.
Yep. See
Bye.
you.